And now I think I'm just gonna take the whole thing here and pull it down to have it all not overlapping with the drawing. And now I have to keep in mind that this thumb force here is negative because it points down. Interestingly enough, the lever arm here is also negative because it points left, and therefore this entire torque is positive, and a positive torque will mean that due to this torque here, there's a rotational torque counterclockwise around this axis. It makes sense because the thumb is pushing down here, so it tries to rotate the tray this way. By the way, that positive torque here being described is on virtually the same page as where it says in the book that the choice of x is completely arbitrary. So these two concepts are if an object is in equilibrium, I should say, so the choice of x is completely arbitrary. So those two concepts about the rotational axis being arbitrary and the positive torque meaning that it's trying to rotate counterclockwise are virtually on the same page. Let's see. The weight of the tray, of course, is negative. The lever arm for the tray is positive, and so that tries to pull it down this way, and therefore clockwise, and then the same happens for all the other weights. So this one is being negative, and this one is being negative, and then the three lever arms here to the tray, to the plate, and to the coffee cup are all positive, and that's why these three torques are actually negative. And these three torques then here have to balance the thumb that is pushing down. Also, this is interesting when you look at a waiter or a waitress carrying these. Since the fingers are off center from the center of gravity of the weight that is actually on the tray and including the tray, therefore there has to be a counter torque, and that's a thumb pushing down. So the thumb here has to exert an appreciable force in order to make up for these clockwise torques trying to pull down. So this has to produce an appreciable clockwise torque and downward force. So the thumb has to exert quite some force in order to counteract these, and at the same time it actually adds to the weight because this force is pushing down. Therefore the fingers not only have to hold up the weight of these here, but also have to counteract the force of the thumb. And of course, if a waiter can do it, they would just take the flat hand and put it under the center of gravity of the tray, and therefore they don't have an additional force pushing down. So that's why I think this problem is also kind of interesting. I'm not going to write down the algebra here, but I'm just going to say, okay, when you do the algebra, everything is given but the t, and then you put that on the other side, it will come out to newtons. And then what you're going to get is, well, all of these here are negative numbers. Everything is given. You know, the mass of the tray is 0.2 kilograms. Therefore, its weight is 1.96 newtons, and actually negative 1.96 newtons. So everything is given. All of these are negative, but when you do the algebra, get them to the other side, they all become positive, divided by actually that negative lever arm right here, that negative lever arm, which actually makes the force exerted by the thumb negative, which makes sense because it's pointing down. Then you can use that result for the thumb and change the rotational axis to, for example, anywhere else, and then calculate what F is. Or you can just put the center the rotational axis right here and calculate the force from that. Or you can use Newton's original second law and then say, okay, I got the thumb pushing down plus the F pushing up plus all the other weights tray, plate, that was supposed to be a P, coffee cup, and that of course equals 0. And then the only unknown here is F, so that one therefore will come out to F equals something. And then all these here are negatives. All of these are pointing down. This one here is negative as well. We just calculate it here, get everything on the other side, which makes everything positive, and you will see that that force here also comes out to a positive.